In November 1992, a construction crew building a highway extension through San Diego County hit something in the ground. The machine stopped. The paleontologist on call, a man named Richard Cerruti from the San Diego Natural History Museum, whose job was to be present at exactly this kind of moment, came forward and looked at what the blade had disturbed. What he saw were bones, large bones, ancient bones, dark with the mineral staining of extreme age, embedded in fine sediment that had not been touched since the Pleistocene epoch. He flagged the site, the machines were pulled back, the area was blocked off, and the careful, painstaking work of excavation began. What came out of that ground over the following months was so strange, so resistant to easy explanation, and so threatening to everything archaeology believed it knew about the human story in the Americas, that the scientists who found it spent the next 25 years verifying their findings before they were willing to publish. When they finally did publish, in April 2017, in the journal Nature, the most rigorous and prestigious scientific publication in the world, the response from the archaeological community was immediate, fierce, and deeply divided. One researcher said the paper was astonishing, not because it was so good, but because it was so bad. Another said it could force a complete rewrite of the story of humankind. Both of those reactions came from credentialed scientists. Both of them, in their own way, were telling the truth. And the question at the center of all of it, a question that has still not been definitively resolved, is one of the most consequential in the entire history of American archaeology. Was something here in California 130,000 years ago? And if so, what was it? To understand why that date is so explosive, you need to understand what the scientific consensus has held and continues to hold about when human beings first arrived in the Americas. The dominant model, supported by decades of genetic analysis, archaeological excavation, and climatic modeling, places the first crossing of human beings into the Americas at somewhere between 15,000 and 25,000 years ago. The route, according to this model, was the Bering Land Bridge, a broad expanse of land exposed during the last ice age when sea levels dropped far enough to connect what is now Siberia to what is now Alaska. Bands of Homo sapiens, following herds of megafauna across that land bridge and gradually dispersing southward as the ice sheets retreated, populated the entire Western Hemisphere within a few thousand years. This model is not without its complications. Sites like Monteverde in Chile, which has been dated to approximately 14,500 years ago and sits at the very tip of South America, have pushed researchers to think harder about how quickly migration could have occurred and whether coastal routes along the Pacific shoreline allowed movement faster than the overland corridor model predicted. A handful of other sites have generated controversy by suggesting earlier dates at 20,000 years ago, 30,000 years ago, even older. Each of these claims has been examined carefully, debated intensely, and in most cases found wanting by the majority of specialists in the field. Nothing, however, had ever come close to 130,000 years ago. At 130,000 years ago, Homo sapiens as a species was still confined to Africa and, at its most adventurous, the edges of the Middle East and southern Europe. The peopling of East Asia had barely begun. Australia would not be reached by modern humans for another 50,000 years. The idea that any member of the genus Homo, whether sapiens, Neanderthal, Denisovan, or some other archaic relative, had crossed into the Americas at 130,000 years ago was not merely controversial. It was, by the standards of everything archaeology had established, impossible, which is why when Tom Desmarais, the paleontologist at the San Diego Natural History Museum who had taken over the analysis of what Cerruti had found, looked at his data and said out loud, "I realize that 130,000 years is a really old date and makes our site the oldest archaeological site in the Americas." The room around him went very quiet. The site is called the Cerruti Mastodon Site, named after the man who flagged it in 1992. It sits beneath what is now State Route 54, a highway running through San Diego County in Southern California. The bones found there belong to a Columbian mastodon, a massive, elephant-like creature that roamed North America from the Pliocene through the end of the Pleistocene, going extinct around 10,000 years ago, along with most of the other American megafauna. Mastodons were common animals in Pleistocene California. Finding their bones at construction sites is not unusual. What was unusual about the Cerruti site was everything else. The mastodon bones, femurs, molars, tusks, ribs, vertebrae, were not arranged the way fossil bones typically are. They were concentrated. Certain elements were present in specific configurations. 2 femur heads, one facing up and one facing down, broken in an identical pattern. A tusk planted vertically in the sediment, upright, like a post driven into the ground. Bone fragments clustered around certain areas rather than scattered, randomly as they would be in a natural death site. And most significantly, 5 large stones, ranging in size from cobbles to boulders, found in close association with the bone concentrations. Stones that did not belong to the local geology, that would have had to be brought to the site deliberately, and that showed damage on their surfaces, consistent with having been used to strike hard objects repeatedly. The team's interpretation of this evidence was explicit and careful. They proposed that the Ceruti site was a bone processing location, a place where an unknown hominin had used the 5 large stones as hammers and anvils to break fresh mastodon bones, not to butcher the meat, but to crack open the dense femur bones and extract the marrow inside, which is a rich, high-fat food source documented at hominin sites across Africa and Eurasia going back more than 1 million years. They proposed that the unusual arrangement of bones was the result of deliberate activity, bones moved, sorted, and broken by a creature with intentionality. And they proposed that the age of those bones, established through uranium-thorium dating by James Paces of the U.S. Geological Survey, was 130,000 years old, plus or minus 9,400 years. To support their interpretation that the bones had been broken while fresh, rather than after fossilization, which produces very different fracture patterns, the team conducted a controlled experiment. They obtained the bones of a recently deceased elephant in Tanzania and struck them with stone hammers, documenting the fracture patterns produced, the spiral fractures, the percussion notches. The half-impact marks they found on the Ceruti mastodon bones matched what their experiment produced when fresh bone was struck with stone. They were not, in their assessment, the random fractures of geological compression, animal gnawing, or accidental damage. They were the marks of deliberate, skilled bone breaking by something with hands and the knowledge of how to use them. The paper was accepted by Nature after peer review, a process that is not casual or perfunctory at a journal of that standing. The reviewers who evaluated the manuscript before publication did not reject it. They found the evidence sufficiently compelling to warrant publication, with the understanding that extraordinary claims in science are not settled by a single paper, but by the weight of subsequent research and replication. When the paper appeared on April 26, 2017, it generated the kind of global scientific reaction that very few archaeological papers ever produce. The coverage was immediate and massive. National Geographic, The Washington Post, The Los Angeles Times, Live Science, and dozens of other outlets ran the story within hours. And alongside the breathless coverage came the pushback, not from internet commenters or alternative archaeology enthusiasts, but from some of the most respected names in American archaeology and paleontology. Donald Grayson, an archaeologist at the University of Washington with decades of expertise in North American prehistory, was among the first to respond. He did not mince words. He said he had read the paper and was astonished by it, not because it was so good, but because it was so bad. Gary Haynes of the University of Nevada, Reno, a specialist in fossilization and bone damage, pointed directly at the most fundamental problem. The bones were initially exposed by a construction backhoe. Backhoes weigh 7 to 15 tons or more. Their weight pressing down through sediment onto buried bones could crush them against each other, and against the stones in the same layer. The spiral fractures and percussion marks that the research team interpreted as deliberate human activity, Haynes argued, could not be definitively distinguished from the damage caused by a piece of heavy construction equipment grinding through the sediment above them. Michael Waters of Texas, A&M University's Center for the Study of the First Americans, raised a different and complementary objection. The genetic evidence for the peopling of the Americas, drawn from the DNA of hundreds of ancient and modern indigenous individuals across both continents, consistently points to a founding population that arrived no earlier than 25,000 years ago. If a hominin had been present in California 130,000 years ago, it had left no detectable genetic trace in any human population alive today. Either the population went entirely extinct without contributing any descendants to later groups, possible but requiring explanation, or the date is wrong, or the interpretation is wrong. The critics also noted what was absent from the Ceruti site. There were no flaked stone tools going to warrant the kind of deliberately shaped cutting implements that are the diagnostic signature of hominin presence at sites across Africa, Europe, and Asia. There was no charcoal from fire. There were no cut marks on bones indicating butchery of meat. There were no human remains of any kind. The entire case for human activity rested on the arrangement of bones and the damage pattern on 5 stones, in a site where heavy construction machinery had passed through the overlying layers. Desmarais, who had spent 25 years preparing this paper and who had anticipated the criticism, pushed back on each point methodically. On the construction equipment objection, the lead study author, Stephen Holen, said it was very easy to tell the difference between fractures made by stone hammers and those produced by bulldozer. Compression, though he did not elaborate in detail on how those differences manifested, a lacuna that critics found frustrating. On the absence of flake tools, the team argued that a bone processing site focused solely on marrow extraction would not necessarily require cutting tools, only hammers and anvils. On the genetic evidence, they acknowledged the tension but noted that a population that went extinct 130,000 years ago would leave no trace in the genetic record of later arrivals. And Desmarais acknowledged, with the quiet honesty of a scientist who had spent a quarter century on a single question, that one site does not a new paradigm make. But he added something that the critics could not easily dismiss. We encourage the scientific community to reconsider the current paradigm and to attempt to replicate this find by looking in places that may have previously been written off simply because they were thought to be too old. The uranium-thorium dating at the center of the controversy deserves its own moment of examination, because the age of the site, 130,000 years, is not in dispute in the way that the interpretation of the bones is. Uranium-thorium dating is a well-established radiometric technique used widely in geology and archaeology. It works because uranium dissolves in water and is incorporated into bone during fossilization, while thorium does not dissolve and is therefore absent at the moment of burial. Over time, uranium decays into thorium at a known and constant rate. By measuring the ratio of uranium to thorium in a fossil, scientists can calculate with high precision how long the bone has been in the ground. Jim Paces of the U.S. Geological Survey applied this method to the Karuti mastodon bones in 2011 and 2012, using state-of-the-art instrumentation. His result, 130,000 years, plus or minus 9,400, was not challenged by the site's critics. The bones are genuinely that old. Nobody disputes it. And what is disputed is what happened at that location 130,000 years ago, and whether the evidence that something other than geology was responsible is strong enough to overturn a century of archaeological consensus about when the Americas were first populated. The question of who or what might have been in California 130,000 years ago, if the Karuti team is right, is one that the paper itself does not resolve. The authors are careful to say only an unknown hominin species. They do not claim it was Homo sapiens. They do not claim it was Neanderthals, though. Neanderthals were present in Europe and parts of the Middle East at that time period. They do not claim it was Denisovans, the mysterious archaic human population known primarily from DNA, extracted from a finger bone found in Siberia, whose full geographic range is still being mapped. They claim only that something with the cognitive capacity and the manual dexterity to select appropriate stones, carry them to a location, and use them systematically to break large bones was present at a site in San Diego County at a time when, according to everything else archaeology knows, no hominin of any kind should have been anywhere on the American continents. The closest analogy in the broader archaeological record is the behavior of Homo erectus, an archaic human ancestor that had left Africa and spread across Eurasia by at least 1.8 million years ago, that used stone tools, that processed bones for marrow, and that demonstrated a capacity for long-distance movement and adaptation to diverse environments that was far more sophisticated than researchers had initially credited it with. Whether Homo erectus could have made a maritime crossing of some kind, perhaps island hopping across the Pacific, perhaps following now submerged coastal routes, is a question that has been raised in the literature and treated with skepticism, but not definitively ruled out. The Denisovan hypothesis has gained particular attention in the years since the paper's publication. Ancient DNA analysis of indigenous populations across the Pacific, particularly in Melanesia, Australia, and parts of Southeast Asia, has revealed significant Denisovan ancestry in modern genomes, suggesting that Denisovans had a far wider geographic range than the single Siberian cave where their remains were first identified. If Denisovans ranged as far east as the islands of Southeast Asia, and if their range extended into East Asia at a period of lower sea levels, the possibility of a Denisovan presence in the Americas, however remote, is not simply dismissed by geneticists who study archaic human dispersal. In the years since the 2017 Nature paper, the Charuti site has remained deeply contested and largely unresolved. A formal response published in Nature in February 2018 in the journal's Brief Communications Arising section, which exists specifically for critiques of published papers, pushed back against the research team's interpretation of the bone damage evidence. The research team published a reply defending their analysis. The exchange was scientifically substantive and produced no clear winner. The Paleo-America Journal ran multiple papers in 2017 presenting disparate perspectives from researchers who had examined the evidence independently, arriving at conclusions ranging from compelling to unjustified. What has not happened, despite Desmarais' public encouragement to do so, is a replication. No second site has been found in the Americas with comparably ancient evidence of hominin activity. No additional Karuti-type assemblage, bones broken in a way consistent with deliberate marrow extraction associated with stones of the right size and damage pattern dating to anywhere, close to 130,000 years ago, has been reported from any location in North or South America. The Charuti site remains, as it has remained since 1992, alone. A single data point in a landscape where single data points, however compelling they might appear individually, carry limited persuasive weight against the cumulative mass of evidence pointing in a different direction. The absence of replication cuts both ways. It strengthens the skeptic's position. A genuine pattern of early hominin presence should, if it existed, leave more than one site. But it also reflects the reality that sediment layers of the appropriate age are extremely rarely exposed at the surface, that most archaeological sites of any age are found by accident rather than design, and that the entire history of America's archaeology before 12,000 years ago is a history of sites that were actively dismissed and not looked for, precisely because the consensus said they could not exist. You do not find what you are not looking for, and if the Cerruti site teaches archaeologists anything, it may be that the Americas and the deep Pleistocene have not yet been properly searched. The bones sit now in the collections of the San Diego Natural History Museum, carefully cataloged, precisely dated, and stubbornly, persistently unexplained. The 5 stones that may or may not have been used as hammers and anvils by a creature whose species cannot be named are there alongside them. The femur heads, one up and one down, broken in the same way by the same force, are preserved and available for any researcher who wants to examine them. Tom Demarais, who spent 25 years working this problem before he was ready to publish, said something in the aftermath of the paper's release that captures the precise nature of what the Cerruti site represents. He said that the evidence was really compelling, and that he encouraged the scientific community to look in places that may have previously been written off simply because they were thought to be too old. A highway runs over the site now. The sediment that preserved those bones for 130,000 years has been asphalted over. The moment of discovery that Richard Cerruti flagged in November 1992 cannot be returned to, cannot be re-excavated, cannot be supplemented with the kind of additional physical evidence that might settle the argument once and for all. What exists is what was found: bones, stones, a date, and a question that the most careful and rigorous scientific analysis available has been unable to answer definitively in one direction or the other. Was something here in California 130,000 years ago? The bones say yes, the stones say possibly. The absence of everything else that should accompany such a presence says the question is not closed. And the date, established by uranium and thorium decaying in the dark of ancient sediment at a rate that has not varied since the bones were buried, says only this: whatever happened here happened longer ago than the entire history of human civilization, written language, agriculture, and organized society combined. Something was here, or something happened here, or the earth did what the earth does, pressed, shifted, cracked, and rearranged, and left behind an accident that looks, with discomforting precision, like intention. Science has not yet decided which.